Hello, I'd like to thank you for having interest in the Titan Engineering Academy. My name is Robert Parks, and we'll go through a quick presentation of everything about the Academy. I'm the current engineering teacher, and I will be running the Engineering Academy. So first off, it's a 4-year program. Your student will start as a freshman and move all the way to their senior year. It is possible for students to join the program their sophomore year, but juniors and seniors it will not be possible because of the sequence of courses and the way it works. It's a complete academy. We focus on science, technology, engineering, and math. And for those of you who haven't heard of it before, that acronym is STEM. That's our bread and butter. That's what we focus a lot on. They're grouped together in multiple classes. What we are focusing on is grouping them together in engineering, math, and science. And then we'd also like to group them together in our English courses because English for engineers would be kind of unique. They have the opportunity to go on lots of field trips, job shadowing. We have a VEX Robotics team on campus. We're going to be offering internships. They're going to receive lots of guidance, lots of support, and lots of encouragement to figure out really what they want to do when they graduate and how to get there. So the goals of the Academy are pretty straightforward. We want them to get interested in different STEM careers, be it engineering, all sorts of disciplines of engineering, computer science, or really anything science and tech related. We don't expect them all to become mechanical engineers. We want them to see what's out there, to get ideas, be creative, and kind of focus on what do I want to do when I graduate. We want to give them lots of good engineering and technology skills. They'll learn all sorts of cutting edge equipment, softwares, things of that sort that are industry standard. It's a big deal for us to help them figure out what they want to do when they graduate and how they want to continue their education. They're going to get lots of skills and certifications. That's one of our major key elements of the program is we teach our students things that will help them get jobs and succeed in college. And kind of our bar for all of our students is we want to prepare them to go to a school such as Cal Poly Pomona or Cal Poly San Luis Obispo. And as a side benefit, which is kind of an important one, is we want them to have a lot of fun. We want to enhance their high school career. We want them to enjoy coming to these classes and to get excited about their future. So when your student enters as a freshman, the kind of cornerstone of that year is their Intro to Engineering Design course or Computer Science, which is our VEX Robotics class. All the freshmen will be in either one of those, and it'll switch their sophomore year. They will be in either Algebra 1 or Geometry. They'll be in some sort of English class, Advanced Biology, and they'll also take our Health Science and Workplace Safety course. That's part of the Academy. It's like the district's health requirement for a class, but we also add a lot of CTE, and CTE stands for Career and Technical Education. So we have some special things we have in play for that. And then all freshmen do take PE. As a sophomore, their engineering and computer science class will switch. So if they had Intro to Engineering as a freshman, their sophomore year they'll have computer science. If they had computer science as a freshman, they'll have Intro to Engineering as a sophomore. It just goes back and forth. They'll progress on through their math courses. They'll be in either Geometry or Algebra 2. They'll be in an English 10 class, and then they'll also be taking chemistry, most likely honors chemistry because it's very lab-based, and labs are a big deal for engineers. Outside of the academy, they'll take either World History or AP World History. They'll take their first year of a foreign language, and they'll take their next PE class. And due to the fact that they can only take 6 classes where they're in class during the day, they'll also take online PE. Junior year, they come back to engineering. All students will take CAD/CAM engineering, which is a 1-year course with a focus on running our CNC machines, such as our Haas milling machines, our Tormach milling machines, our CNC lathe, our CNC water jet. This is a big hands-on computer programming type class where they run all of our machinery. They'll take their next course in the sequence of math, so they should be up to Algebra 2 or Pre-Calculus by now. Another English class, and then for their science class, they'll more than likely be taking physics or AP physics. And then outside of the academy, they'll take US history or AP US history, and their second year of foreign language. As a senior, we give them another choice. So up to this point, they've taken 2 engineering classes and 1 computer science class. Now, seniors are going to get a choice. They can take advanced CAD/CAM engineering, which is more hands-on, more running our Haas machines, more project-based certifications, things like that. They'll be in the lab a lot. Or they can take AP Computer Science. So after a year of computer science and 2 years of engineering, maybe they decided that their interest lies with computer programming, computer science stuff. So instead of forcing them all to take one class, we're going to give them a choice. And this is really up to them. The next math class they'll take in the sequence would be pre-calc or calculus, and we encourage all students to take 4 years of math, no matter what they want to go into. Computer science, engineering, a machinist, anything like that. There's a lot of math involved, so they need to be good at this. It also makes them more competitive for college applications. Their senior year, they'll take expository reading and writing, so it's about as hands-on as an English class can get. Lots of technical reading and writing. We do recommend, it's not a graduation requirement, and it's not even an A through G requirement to go to a UC or Cal State, but we do recommend a 4th year of science because you're more competitive. You're going into a STEM field. You need lots of engineering and science, or math and science, excuse me. So we're going to have most of our students take AP Environmental Science. Then outside the academy, they can take government and econ or AP Government. Either one's fine. They have to take their 3rd year of foreign language. To get accepted to a Cal State or a UC, you need 2 years of foreign language, but 3 is really needed to be competitive. Now, we're running out of room here. So what we recommend is the summer between their junior and senior year, take an art class at a community college or online. Our counselors can help you out with that. It's either free or cheap, and it's well worth your time. It works for them to be accepted to Cal States and UCs. They need an art class, but it also counts for units for their college career. So you get to kill 2 birds with 1 stone there. Now, if you're unable to do that, something is going to have to give because you can only take 6 classes. And as you can see, there are 7. So they'd have to give up, if they hadn't taken an art yet, they would have to give up either the 3rd year of foreign language or the 4th year of science to make room for it. Now, one of the really strong suits of the Engineering Academy is our focus on college credit and certification. So while being part of the Academy, your student can earn up to 9 units of college credit from Norco College. There are specific requirements for each class. Some of it involves testing, some of it involves projects. Your student will get an official transcript from the college. It is a transcript that can be carried anywhere. They can take it to whatever university they want to go to. It's just like they took a class. Now, it depends on their major. It depends on what university, what it gets used for, but we've had a lot of good success with this. How much does it cost you? 0. I think in the end, it's going to cost you $15 to request the transcript. So up to 9 units. That's a big deal. We also really pride ourselves in our students receive professional certifications. These aren't little plaques or little pieces of paper that we make in class. These are tested by and issued by professional industry recognized corporations. So students can earn several SOLIDWORKS CAD certifications, several Mastercam CNC programming certifications. The freshmen, when they take our health science and workplace safety class, they can earn an OSHA safety certification. In that same class, they can earn their CPR certification and a first aid certification. So after 4 years, your student really leaves with a lot on their resume. All of this stuff is great for college applications. All of it is great for jobs. Now, a PowerPoint and video does not do our lab justice. The Titan Engineering Lab is better than anything you will see on any high school campus, really. We keep up with colleges with what we have. So when you walk in, you'll see our students sit at a 32-station CAD/CAM computer lab. We routinely update our computers, get newer, faster, better ones. Each student sits at their own computer. They're loaded up with SOLIDWORKS and Mastercam, which is both industry standard software. We have 4 Haas CNC milling machines. These are large milling machines that you would see in any machine shop, engineering shop. Large aerospace companies use them. They're industry standard equipment. They're very common. There's bigger stuff out there. There's fancier stuff out there. But if a kid coming out of high school knows how to run these, they have a lot of promise for a career. We have 2 Tormach CNC milling machines. These are smaller ones. They're still pretty big. These are what our freshman students first learn to use. We have a Tormach CNC lathe, we have a couple 3D printers, and we recently purchased a FlowJet CNC water jet. So that is definitely something you don't see in a normal high school. It uses high pressure water to cut through thick pieces of metal like aluminum and steel up to 4, 5, 6 inches thick. One of the biggest things your student gets to do when they're in the engineering academy are the yearly design challenges. Design challenges are where students work in teams or by themselves, and they have to build something to complete a task. Our three biggest ones, we have some smaller ones, but our three big ones that the kids get most excited for. In the fall, we have our walk on water competition where students have to design, test, and build shoes to walk across the pool. They then race each other across the pool. We also compete in the balsa wood bridge competition. It's a standard competition that's sponsored by various civil engineering societies. Students are given 1/4 inch by 3/8 thick balsa wood, and they need to be able to hold as much weight as possible. There's lots of restrictions on it, lots of rules they have to meet. They design the bridge on our CAD software. They then do a stress analysis with it to see how much it should be able to hold, and then they test it to failure. That's an entire day competition. It's a big deal to the kids. The third and other really large competition is our CO2 dragsters competition. So students design a CO2 dragster. It's kind of like Pinewood Derby if you've ever been involved in Boy Scouts, but instead of just letting the car roll down a ramp, we put a CO2 cartridge in the back of it and we shoot it down a 60-foot racetrack on a wire, and they race head to head with each other. The cars get designed in our CAD software. They flow test them in our CAD software to test for the drag coefficient. They build them and race them. So it's a big deal to win this competition. Normally each year we have 40 or 50 cars racing in it. They do get to work with a partner, so not every kid builds one on their own. It's a big deal, and they love doing this. We have a bunch of other small design challenges, but these are the three big ones that everybody kind of waits for. So beyond the classroom, we do a lot of interesting stuff. This is a career where we want you to see things, come up with cool ideas, get motivated. So the more we can expose the kids to, the better. We do lots of job shadowing, lots of tours. So every student will never have an excuse that they've never been to a college. We tour many colleges in the area. Some of the ones we routinely visit, but not every year, are Cal Poly Pomona, San Diego State, UC Irvine, UC San Diego. We also go to University of San Diego. We've been to UCLA, USC, Harvey Mudd, all sorts of places to kind of open their eyes. It also motivates them. They realize, hey, this is why I'm working so hard. We've been very lucky the last several years. We do a SpaceX tour, and by SpaceX, I mean, yes, that SpaceX, the one that's trying to go to Mars. We also tour different aerospace engineering companies and machine shops. One of the big ones we go to is called Absolute Technologies. They're in Yorba Linda, Anaheim area. One of the largest machine shops I've ever been in. Just cutting edge stuff, makes things for the Joint Strike Fighter, the F-22 Raptor, SpaceX. Each year we try to go to the drag races. Aside from the fact that it's cool to go watch cars race at over 300 miles an hour, there is lots of engineering that goes on in a car that produces 6,000 horsepower. We've been going to the Disneyland Science and Engineering Day because there's a lot of engineering and science that goes on in roller coasters. And then some other places we've been to in the past are Edelbrock Performance. They make hot rod parts. We've gone to a bunch of different motocross companies like Suzuki Motorcycles, KTM, Honda. Really, we're open to just about anything where we look at it and go, hey, the kids would like this. So we want them to see that kind of thing. Part of our program is the new VEX Robotics Club on campus. So it's used heavily in the academy for their classes. It's a big part of computer science, obviously, and AP computer science. The engineering classes, we do a lot of design work and manufacturing for the competition. It counts as a club, lots of extracurricular activity stuff, lots of community service, but the students also compete. Looks great on college resumes. It gives them a lot of hands-on experience, problem solving. It's a fantastic program to get the kids excited about it. We're one of the few high schools in the state or in the nation that has a Society of Women Engineers and Scientists Club. We took it from Society of Women Engineers, which is a club you'll find on just about any college campus. We added scientists to it because we get girls that are interested in STEM fields. It's a club that focuses on women's empowerment, bonding, and positive attitudes. They go on field trips, tours, they have guest speakers, they have bonding activities. And Mrs. Parks, who's our health science and workplace safety teacher and also a health teacher on campus, she's the advisor for that club. So how do you get in? The first thing is you need to have decent grades. Our prerequisites are a B or higher in pre-algebra, if you took that in 8th grade, or a C or higher in Algebra 1. So we're not asking for too much, but that just needs to be met. You're looking at a career with a lot of math. You have to complete an application. I'll give you that link later on. If you have any major discipline records, we're just really not that interested in you. We have to trust you. We have to know that we can have you working on very expensive equipment and be able to follow safety rules without being a problem. You need to have a strong commitment to the program, its requirements, and expectations. We expect a lot out of these students. They're choosing a very difficult, stressful, and not easy to get through career. So you need to kind of be all in. You need to take it seriously, and you need to think this through, because you're going to be taking some hard classes, but the rewards are just huge. And the biggest thing is we want every student in the academy to have a positive attitude, to really want to learn this stuff, to be excited about making things, to get excited about, being someone who designs stuff that goes to Mars, or race cars, or bionic limbs, or heart valves. Anything that gets you excited where you get to build things. That's the kind of kid we want. So the application's available online. Everyone has to fill it out. It's a simple Google form. It's multiple choice for a lot of it, and then some short answer questions. To go to it, it's that link right there. You'll notice there is no www. Don't try to put that on there. It's http://tiny.cc/Titan Engineering app, and that will take you to the application. Now, when you fill it out, it does send it directly to me. I'll get to see all of it. We don't put a due date on it yet. We have to change that every single year, so you'll have to be aware for that. But the sooner you get this done, the better. Normally by mid to late January, we want to get this done. If you have any questions whatsoever, please feel free to email me. Again, my name is Robert Parks. I run the engineering program. I'll also be running the engineering academy, so I can pretty much answer every question you have. Don't be afraid to contact me. I will be happy to field any of your questions. And I hope you found this pretty informative, and this gets you all excited about our engineering program and the Titan Engineering Academy, and we hope to see you.